Okay, we're picking up today with sections 3 and 4. So where we left off yesterday, we're ready to talk about random sampling. So in random sampling, it's basically how you choose the people to be in your experiment. And in random sampling, you just use chance to select the people to be included. There's equal chance of everybody being selected. It is random. It would be like if I want to select 4 volunteers from this class, I put all of your names in a bowl and I randomly draw one out. That is your random sampling. In random sampling, we're going to talk about a few different ways to do it. The first way is just simple random sampling. And so it's essentially just everyone has an equally likely chance of being selected. Every person has an equal chance of being chosen. Okay, so we are going to be talking today about a lot of different sampling techniques. Random sampling, you can see on your notes handout, is the big piece. And then we have 6 different options we're going to talk about for how we might do that. And the first is the simple random sampling, just everyone has the equally likely chance. That's the picking 4 names out of the hat. That would be simple random sampling. In this video today, please, as you're writing down definitions, pause it until you get your definitions down. I'm not going to sit and wait on my end, but you just pause it and then continue playing once you have down what you need. So if I look at this example, we have a study group of 5 students. 2 of them must go to the board to demonstrate a homework problem. List all possible samples of size 2 without replacement. Okay, so that means we could do like Bob and Patricia, or Bob and Mike, or Bob and Jan, Bob and Maria. That's everyone that includes Bob. We've already done Bob and Patricia, but we could do Patricia and Mike, Patricia and Jan, Patricia and Maria. Okay, that's every combination including Bob and Patricia, so we can do Mike and Jan, or Mike and Maria. The last combination would be Jan and Maria. So that is every possible sample of size 2. When I say without replacement, that means once Bob comes up, he can't sit back down and be the second student as well. Okay, they only get to come up once. If we count, we have 1, 2, 3, 6, 7, 8, 9, 10 samples here, 10 possible samples. So the likelihood of a sample containing Bob and Jan, there's only one that has both Bob and Jan, and there are 10 possible combinations. So the likelihood of Bob and Jan coming up is just 1 out of 10. Okay, so to obtain a simple random sample, easier probably, rather than writing names, you could number people from 1 up to n, just being the numbers of people you have, so 1 through 5 there. You can use a random number table. There's one in the back of the book. I don't really use it too much. Graphing calculator or statistical software to randomly generate the number. So I am going to show you how to do this on a graphing calculator. Pause this for a second and make sure you've got that app open. Okay, if you need a place to reference to figure out how to do this, page 25 of your book actually has a blue box at the bottom, Technology Step by Step, and it tells you for our calculator exactly what we have to do in order to generate this random number. So first, you have to enter any number other than 0 on your screen. It does not matter a bit. It's essentially just the seed. It's giving it a starting point. Let's all pick the same number just so our generator will come up the same. So I'm going to hit an 8. Now we have to store this. So right above your on button, there's an STO button. So you hit that. Now we need to go to Math. We are going to go over to Probability. And we want number 1, random. And then hit enter. So right now it just tells me 8. All we've done is store that 8 as a starting point for our random number generator. Now we're going to go back into Math, over to Probability. We want random again. Excuse me, I pushed the wrong one. Let's try Math, Probability. I want random integer, number 5. Sorry about that. Maybe not. Hold on. Okay, I don't think this is what your calculators show, if I recall correctly. At least I know when I'm looking at mine, it comes up a little bit differently. Okay, I know on the graphing calculators in my classroom, once I hit random integer, it looks like this. I am not sure which one the app on your Chromebook looks like, but we can do it the same. My calculator, if it looks like mine, we have to hit a lower and an upper. We're basically telling it what numbers to look between. So if I wanted to look between, let's say, 1 and 20, my lower is 1, my upper is 20. N is how many things we're trying to select, so I only want 1 here. And hit enter. And it gave me a random number of 20. If your calculator on your Chromebook looks like this, you put 1, then you need the comma, it's up by the x squared, and then your 20. And you can just hit enter, and it should give you a number as well. It gave me 20 on the graphing calculator I have in my hand. So a couple different formats that it might look like, but it works the same. Okay, so let's look at an example. The 112th Congress of the United States has 435 members in the House of Representatives. Explain how to conduct a simple random sample of 5 members to attend a presidential luncheon, then obtain the sample. So first, if we're going to do it on our calculator, what you would have to do is make a list. You would number 1 through 435 and assign each of those numbers to a person. After that, we would use our calculator to get a random number. So we start by entering a seed. So you just pick a number. I'm going to do 4. And we do store, go into Math, over to Probability, and we want number 1. We're going to store it as a random number. Okay, next, I have to actually get my 5 numbers. So we have to go back into Math, Probability, and we want number 5, random integer. I'm starting at 1, ending at 435. Remember, your calculator may look like this. I'm going going to, if you have this option, we want 5 members, so we can put my N as 5. And it gives me all 5. You can include that here, or once you get the first one, so you put that in and it tells you 428. If you just hit enter again, it'll repeat it and you can get the next one. You just keep hitting enter until you get all 5 numbers. And so then you would write down the representative that corresponds to each of those numbers and you would have your sample. Okay, moving on to section 4. We're going to cover this first piece today. It's going to build on those sampling methods. So I just mentioned simple random sampling, and we're going to add in the others. So the next type, I've put a picture on your handout to kind of illustrate this. It's a stratified sample. So in this case, you separate your population into non-overlapping groups, they're called strata, and obtain a simple random sample from each. So it would be like, I go to the lunchroom and I take each table as a strata, a separate group. They're non-overlapping, nobody's sitting at 2 tables. And then I randomly assign each person at that table a number and use my calculator to generate the random numbers. So I pick some from each group. So I pick maybe 3 people from each table. So they were in strata, they were in separate groups to begin with, and then I chose a couple from each group. Systematic is obtained by selecting every K individual from the population. So I go to the lunchroom, and as people come in, I say I'm going to take every 7th person that walks in the door, and I get my group or my sample that way. In a cluster, we select all individuals within a group. So I go to the lunchroom, each table is a separate group, and I just pick one table and take everybody sitting at that table for my sample. So we've got separate tables, and I just take one entire table to create my sample. Again, please pause this while you write down these definitions. Alright, so looking at our example page. In 2008, Senate had 47 Republicans, 51 Democrats, and 2 independents. The president wants to have a luncheon with 4 Republicans, 4 Democrats, and 1 other. Obtain a stratified sample in order to select members who will attend the lunch. So this is stratified because they are broken into groups. We have the Democrats, the Republicans, we have other. Nobody fits into more than one of those groups, so they are non-overlapping groups. Then I know how many I want to pick of each. So we would use our random number generator on our calculator. So I'm going to store maybe a 2 as my seed. So 2, store, math, random number. Then you can go into your probability. You want number 5. For my Democrats, we had 51. So I would do from 1 to 51. And you can either enter all, have it do all 4 at once, or just keep hitting enter and it will give you a new one each time. So I get these numbers when I did a seed of 2. So then if I had an alphabetized list of my senators, I would just take the Democrats in each of those positions. So same thing with Republicans. You make an alphabetized list, you give each one a number. We have 47, so you do your random number generator. Let's say I set my seed at 3 this time. And it can be anything you want, but depending on what you pick, you will get different numbers. So I go to probability, rand, you store that. And then we can do our math probability random integer. I have 47 Republicans, so I do 1 to 47. And if you just keep hitting enter, it'll tell you all of them: 12, 27, 32, and 20. So you take the person in each of those positions. For the other, again, set your seed. Let's say I did 4 this time. If you are having any trouble with this random number generator on your calculator, please pause your video, raise your hand so I can come over and help you get it. We only have 2 independents, so it's only going to go from 1 to 2. And it tells me I want number 2, person number 2. So I just had a stratified sample. I took each group and then I randomly selected people from each individual group. Example 2. A quality control engineer wants to obtain a systematic sample of 25 bottles coming off a filling machine to verify the machine is working properly. Design a sampling technique that can be used to obtain that sample. So there's lots of different options, but I've asked you to do systematic. So that means you pick every kth number. In other words, you just pick, basically depending on how many you want. If you wanted a lot, you should pick like every 3 or 4. Let's say I said I wanted every 8th bottle. So I might survey every 8th bottle. Starting with, you don't just have to start at 1 and then get your 8th one from there. It's kind of like the seed. It tells you where to start. So I might start with the 3rd bottle. And we are trying to get a sample of 25. So I'm going to start with my 3rd bottle, pick that one, then I'll do every 8th bottle from there until there are 25 bottles. Now again, I don't know how many bottles this machine puts out in a day, so if it's putting out 5,000 bottles, I probably don't want to just take ones from the beginning. So if it were putting out that many, I might need to pick every 100th bottle or something like that. If it's only going to put out 50 bottles, then every 8th might be sufficient. So you can kind of choose your K value depending on how many you want. If we know our population size, we can get our K by taking the population divided by the sample size needed. So in other words, if there were 200 bottles being produced in a day, and I want to get a sample of 25, you simply divide those, and that tells me that I need every 8th bottle. So that would be my K value. You round down if needed, so if there were like 306 produced in a day, and I need 25. So 306 divided by 25 gives me 12.24. So we would use 12 for the K value. Okay, so that helps you spread it out, so you're not only picking samples from the beginning or the end when you're looking at them. Alright, let's do another example. school administrator wants to obtain a sample of students in order to conduct a survey. How could this be done with a cluster sample? So a cluster sample, everybody's divided into groups, and you pick an entire group to do the survey. So I could say that each class is a cluster. Those don't overlap. You don't have people in two classes at once. And then you randomly choose an entire class. To survey. Okay, so you divide them into groups and take the entire group. Two more types that we need to mention. We have a convenience sample. Convenience sample is just where they're easy to obtain. Okay, so it might be, I want to survey how many of our seniors are going to college. And so I just ask my calculus class how many of them are going to go to college. It's easy because I'm already seeing them anyway, they're all in my room, but it's not especially good because they don't necessarily represent the entire student body. They're probably taking that class because they're going to college. So this is not a good method. It's easy, but it will be biased. Your results will be skewed. The final thing that I need to mention is multi-stage sampling. This is done for large-scale surveys. So if you're thinking about the census or something like that, they have stages of their samples. It helps them collect better information. So one example, there is a research company that selects households and monitors what TV they watch. So they put a box on the TV in the household and then monitor it. They use a two-step model. The first step, they took the data, divided the country into regions, and basically stratified it. They got different strata, like city blocks or geographic regions, and took those. So they did start out stratified. They broke them into non-overlapping groups. Then they send people to the strata and randomly select from within that. So it's not just a clear-cut one-step process. Multi-stage is just using a combination. You might use some clusters, but then also do something systematic within that cluster. Okay, that is the end of section 4. So that is our stopping point for now. Your homework. Page 27, going to do 8 and 11, and on page 34, 12 through 22 even, 26, and 28A.